students. I guess all the audience are the students only, or how it is. So just I know I want to know about the
Uh,
audience. Yeah.
no, there are faculty from chemical engineering, there are industry
Mhm.
participants and
Great.
students.
Great, great, great. Perfect, perfect. So yes, welcome all. So yes, Mr. Ramesh has explained many things about my profile. Yes, I hope this coming 2 hours will be justifiable to what the introduction has been given. Let's, as always, I do. Let's keep this conversation as or this session as session conversational. You can just raise your question. I don't know the speakers are mute, so I'm not sure how you will ask the questions, or maybe you can put in your question answer session or something.
Sir, I will
And
make the unmute. If you want, I can make the unmute button. I can press them. No problem.
Perfect, perfect, perfect. So just keep on asking. Yes, you definitely you will have many questions. I attended such forum earlier as well. I started this journey of this giving the lectures and then talking with the other people, her knowledge sharing and everything from the Bharati Vidyapit in 2009 21. I have delivered the first lecture, and the audience that time was again the faculty member and the students, and the response or the questions were amazing, which helped me to further learn more about my expertise itself. So yes, just keep on asking the question, and keep this session interactive. I have prepared the PPT to share with you, so that we will have something handy to talk about. So I will just share my screen, and one of you just let me know if you can see the screen. Yeah. So yeah, I will go into the PPT mode, and just someone may just quickly raise the hand and just let me know if the screen is visible. Perfect, perfect. Thank you. So let's go ahead. So yes, basically this is myself, Chetan Badhe, and giving you some knowledge sharing or whatever I learned through this 16, 17 years into the digital twin in chemical and the manufacturing sector. The contexts which I have crafted are like journey of the concept of this digital twin, then the deployment and challenges which I have faced, plus what my colleagues in the industry faced in this deployment in these digital twins, then industry prospects about the digital twin, use cases which I have myself witnessed, use cases which are failed, and which have witnessed by my colleagues as well. So those things I will explain you, so that you will get the 360 degree picture, what the exactly digital twin, how it is useful to us, to the industry, and of course the other organizations. And then last, the conclusions and questions. I will not mind if this session has stretched after 2 hours or something. So just whatever is the question, keep on asking. Yep. I had full of my lunch, and so I'm okay to stretch as much as you want. So let's start first. Understand myself. What is Chetan Badhe, my journey and everything. I will quickly go through it, and then we can move to the for the digital twin journey. So myself, I did my chemical engineering from Bombay University in 2008 from the MGM college. You must be knowing because you are from the same university. So I completed it in 2008, and then I was not much good in my academics, because I was good at my cricket. So hence academic is not good. So that's why I'm only Chetan Bade, not a Dr. Chetan Bade or the MTech Chetan Bade something. So just a B chemical person. And after that, in a campus I joined the ion exchange. So I started this journey of the techno functional role in the ion exchange. It's a water treatment company in Rabale. So I have joined there as a trainee and worked for almost 1.5 year. And being a chemical engineer, so the thoughts were like we should work in the refineries and the oil and gas and everything. So the water is not the exactly chemical engineer's role. So that kind of maturity I was having in 2008 and 9, and so I have just moved into the another organization, which is triangle simulation. And why I have mentioned the triangle simulation here, because the journey of my simulation or the digital twin or whatever we call it started from this company only, where they used to do the coding in the simulation and everything. Then after triangle simulation, I have delivered the projects on the refinery as well as the power plant, coal thermal power plant, which is in the Chandrapur. So that particular project I have delivered, and then I joined the Evonik Industries, where I have delivered couple of more digital twin or the simulation project for the power plant. Then moving further, then for around 10 years, I was with the Honeywell Automation, right from 2012 to 22, and I played multiple role there. I got three promotions in the Honeywell, plus roamed across the world through the Honeywell for so worked with the multiple caste, culture, and religion people, which was kind of a great experience which I had, and I was very much grateful with the Honeywell about that. Uh, Worked mostly on the refineries and oil and gas industry in the and little bit of power plant, hydropower plant project in the Honeywell Automation. And my the predictive maintenance, then this data science machine learning journey has been also started in the Honeywell Automation only. So the typical curiosity turn I have took in the Honeywell Automation, and then till this time I was working as a service provider in the triangle simulation, in the ion exchange, Evonik, and the Honeywell. So in Honeywell, I thought that okay, now let's turn the table and let's see how industry see those solution as a person who is already implementing in his company. So that's why I have joined the IG Petrochemical. And in this IG Petrochemical, I was sitting at the customer and the other companies who are giving the digital twin or the simulation were my vendors. So they used to give the solution, or we used to build it in-house into the IG Petrochemical and implement it across the plant. So that was a totally different experience where I learned about the till the time I was learning about the solutions and the chemical engineering and the simulation thing, digital twin, predictive maintenance, pattern recognition. But in IG Petrochemical, I have actually learned what the industry is, what industry want, what are the gaps which are uh, between these solutions which are provided by the different companies, digital solution or whatever the services and everything, and what industry exactly expect. So that I learned in the IG Petrochemical. In parallel to that, continuing this learning journey, formally I have completed my post graduation certification from the Indian Institute of Science, Bangalore. And the certification was about the Industry 4 and smart factories and the Industry 4. So that I have completed, where I got to learn different robotic things. Then Microsoft about the Microsoft HoloLens, how this technology can be used or cannot be used in the industry. Those things I have learned here. Then then one big change I have took. So till this 12 years I was with the oil and gas petrochemical, the power industry and everything. So now here I thought that okay, let's now try the renewable industry, wind energy. So I have joined Suzlon Energy, and I was handling a team of around 30 people in Suzlon Energy, which includes the data scientist plus some UI UX expert, project manager, and the electric engineers, of course. So that is how I have reached Suzlon. And then uh, because of my some family responsibility, I need to switch back. I need to do work from home. I need to support my family. So that's why I have left Suzlon and I have joined the Hempel Paint. So here I'm looking after the industry four things. And yeah, that's it. So this is about my entire professional journey. Yes, you can call me Mr. Chetan Badhe, Mr. Badhe, or whatever you want. Doesn't matter. Now, okay. Now, what this digital twin or predictive maintenance or the simulation? So how this term has been tossed. So till the time, so I have just went through the whole our your program schedule and everything, and everywhere we were talking about how the AI will be useful in the industry in the industry or for the chemical engineering, for the manufacturing, how the Gen AI will be useful, how the digital twins are, predictive maintenance are. So yeah, just I will start from the beginning scratch what the initial digital twin was about. So earlier, so having the DCS and SCADA itself is, so this digital twin is kind of very vague term. Multiple things comes under it. So recently when I was talking with one customer, or not a customer, we can say it is at the end user, and he was just showing the level of the vessels into the Power BI dashboard, and he was calling it as a digital twin. As per his concept, whatever is happening in the plant, what is the level of my particular vessel or my the reactor or everything, if I'm showing it on the Power BI dashboard or any dashboard, then it is a digital twin because it is a replica of the plant, and he was right at his place. But yes, likewise there are multiple definition of the digital twin. So as per me, the first, so there is no defined definition of what the digital twin is. So as per me, these DCS and SCADA things, or the PLC HMIs on all these things are the first industrial digital twin as per my definition. Yeah, and which are kind of most useful thing, because this is the thing which is automate the plant and which run the plant, and the plant which is actually producing the product and generating the revenue. So this is the first earlier digital twin, I can say. The advancement over it in around 1980 85s or something, people have started writing down the codes and everything, and those code based simulation has been come into the market. In this, typically the nature, and where I was in 2012 when I have joined the triangle simulation, we were also used to write the code in C++ and do this simulations. And simulation is nothing but the replica of the plant, not the real time replica, but how your plant is exactly built. We used to write the code, and operator used to train on those codes, or basically, or the simulators. The graphical representation are exactly same as they were doing into the DCS. So whatever operator is doing when he's taking the startup of the plant, or if this plant is not if the plant is malfunctioned, or some discontinuous has discontinuity is happened, or something is introduced in the plant, then how the operator should respond to that, how the operator should take the startup, how the operator should take hot startup or cold startup, maybe these are the more technical term. So those things we used to write in the code with actual measurement, or with the actual feeling of that plant, that how much my vessel, how much my particular reactor will take to fill up when the flow will start. So these actual things are fed into the code. We used to write that code, and likewise the my code or my simulator used to perform. So operator is getting trained on that digital twin or the simulator, and we the end user first let operator work on this simulator, and then he used to go into the plant, so that the chances of mistake will reduce. So that we call as a digital twin or the simulator in earlier era. So yeah, the next part, what the digital twin is, yes, in 2012-13 it was about the writing the code, and then when I joined the Honeywell, I used to work on the drag and drop software, drag and drop software. So if you have witnessed Aspen or the Unisim, then these tools are like, so we used to draw this exact plant studying the P&ID and everything in our tools like simulation, like Unisim and all, and the specification which are given for particular wall or vessel, we used to fed this as an input into the Unisim software, and then accordingly we replicate the plant. So here the requirement of writing the code was reduced. The things are templatized, and when I'm saying I'm dragging and dropping particular wall, it is nothing but I'm calling that code. Of course, there was a code behind the Unisim software and everything, but just the things are more simple now because it has templatized and drag and drop version is available. So yes, so those kind of simulator which we have delivered, so we were calling it as a simulator, and this simulator are attached to the DCS as well. So the logics which are into DCS, like if some, so there are some shutdown logics, or there are some some steps which you need to follow. So those ladder logics and everything are attached with this simulator, so that you will have exactly fail when you are operating it from the DCS. So those simulator we used to deliver. Then next, in around 2017-18, this new era of machine learning and everything has begun. And then the next thing in the market, or the in the picture, is pattern recognition. So in so the digital twin here was like if something has happened in the past, learning those pattern, my program is used to predict how this is the downtime is going to come, or if some equipment is going to fail. Those patterns will those recognizing those pattern based on the real running parameter of the plant uh, is begun. So that's what this new phase is, pattern recognition I am calling it as. And this I learned, and I have worked on the in the Honeywell only. And of course, it is machine learning based pattern recognition techniques, and we used to call it as a digital twin or digital transformation things. And the predictive maintenance, again, when you predict the problem, then yes, you should take action on it. What action, then the cause and effect analysis and everything. So those tools has come up in the market, and which we have delivered through the Honeywell. And then beyond that, the prescriptive digital twin. So when I say prescriptive, okay, based on my earlier patterns, something has been happened, what action operator should take, that case ready is delivered to that operator or to the maintenance person. So that is the prescriptive digital twins, which is latest available in the market and which is the mostly used in the industry. Why I'm saying mostly used? Because this is something which is giving the real results in the industry based on my experience as a service provider, as a end user as well. So this is kind of whole digital twin journey, I can say. Now parallel to this, there were multiple digital twin concept, like when I am visited one uh, what you can say summit. That time the vendor has presented me the solution of Microsoft HoloLens. So in that HoloLens, what was the use case is like, for example, if someone is sitting in Denmark and I'm sitting in Malaysia or somewhere, both are the technical people, and we used to have the 3D map of my plant, and we will just use those 3D glasses and everything, and then someone will enter from that. If something is bad is happening at the plant and live values were there, then I will enter into that environment of the cloud environment through the HoloLens, and then someone who is a maintenance engineer, he will enter into the whole this HoloLens environment, and they will see the 3D replica of that plant, and they will fix that, not actually fix the problem, but someone who is actually at the plant, they will guide that person to fix that problem. So that was the concept. But considering the technology, the ROIs on that, and the practical usability, network coverage and everything, this is not yet much what you can say accepted in the industry, because everything boils down to the money. So yeah, that was not that much expected, and these things which I am showing, these are widely accepted and getting implemented in the industry. So yeah, I talked for almost 20 minutes now. I will take just one quick pause for your questions or your reflections. Anyone, if you have something in mind, you can ask. Yeah, anyone, or should I pick someone? Nita ma'am, how it is? How, I don't know. Ramesh sir.
It's going well,
sir.
Chetan. Till now, it's
Yes, sir.
clear.
Perfect,
You may
perfect.
please carry. Yeah.
May I
Okay.
ask a question, Chetan sir?
Yes, yes, of course, Sriram.
This Unisim digital twin you said.
Mhm.
So does it run in same PC as a SCADA, or you have another server where this Unisim runs?
Yeah, so this Unisim can run on our laptop as well. It can run on the normal PCs as well, because this is just a software. And DCS and SCADA, these require different hardwares. The what you can say, high performing hardware. So this runs on current industry setup. Yes, this different this run on different setup. But if you want, you can install the Unisim PC on the same PC as the DCS and SCADA as well. Yeah, but this is not recommended. Why? Because DCS and SCADA are something which are actually talking with your chemical plant or process plant or manufacturing plant, and it is always advisable not to disturb those software which are actually talking with your real process. That is not safety norm, I can say. Yeah.
Okay, sir. And these both are connected through OPC or any other such protocol?
Yes. So yes, through OPC. See, OPC protocol is something which is used to take value out of the your DCS or SCADA or whatever it is. Okay. And now after taking out of it, after taking those values out, you can use it to talk with either with the Microsoft Excel, with the Unisim, or whatever you want. If you want to pull those values on the Microsoft on our Power BI, you can do it. If you want to just have that while those values on the Excel, you can do it. Whatever it is. So it is just for the pulling out. Yeah.
Thank you.
In fact, that is very interesting question, Sriram. In my coming example, I will again, further elaborate what is use of those things and everything on it. Yeah.
So, Chetan, if you have
Mm-hmm.
Unisim
Yes,
software,
Rajesh. Uh-huh.
then for to develop digital twin, you require another model.
No, if you have Unisim, you will not need another model to develop it. Now, again, it depends what you call digital twin as and what is your exact use cases. If you want to create only the process model, you can create it only in the Unisim. If you want the look and feel as well, same as your DCS or your actual plant, then you need to have one more software upon it. Yeah. So it is a combination. Yeah.
So, what is that software which is look for
So in if you can
additional software?
say right, if you talk about Honeywell technology only, then Honeywell have the Unisim as well as Honeywell have USO, that is Unisim operations. So in those operation you can build your HMI and everything again by drag and drop, and those HMI this HMI layer will talk with your Unisim layer. So in Unisim layer you will do the actual thermodynamics calculation, whatever the temperature, pressure, the flow of the things, the flow of that particular line will be calculated in your Unisim, and the visualization will be done on the USO, that is Unisim operation. Yeah. So this combination you can build in your for your use case, Rajesh.
Yeah, yeah. Thank you.
Yeah. Mm. Further, how we can do it? I guess there are some videos available on the YouTube. I will find it out and I will share those video with you people, Rajesh. So Rajesh, you are from industry or you are from faculty?
Yeah, I'm from industry. I'm from Petrofac.
From Petrofac. Perfect, perfect. For
Yeah, yeah.
Petrofac in
I work in
KOC,
process. Yeah.
perfect, perfect. So now I got the context of your question. So I will further elaborate my answer more. So yeah, as you are in Petrofac, you are the person who is bridge between the end user and the and this operational software and everything. So here, first thing is for these simulations, what you can do, you can have your Unisim where you will build this all the process. What the process flow and everything with actual equipment and everything, which will give you the process values. On top of that, as I said, USO, which will give you the visualization. The third part is the logics, which comes under the ESD. Okay, when my particular pump should be tripped and everything. Those logics are built into the Honeywell DCS or the Aviva DCS or whatever it is. Okay, or the Schneider DCS or Emerson's Delta V for that matter. So simulating those what you can say, those logics and everything, either you can build it in USO or you can take those software like the actual Honeywell's DCS, you can install into the server, and that server will talk with your Unisim model, and you can operate directly from that DCS. So that one more layer of software will come into the picture in this matter. So in parallel, so your one setup, your actual DCS is talking to your actual plant where the people are operating and the things are happening in the plant. Parallelly on your simulator, you can operate it from DCS, which is talking to your simulation plant where you have built the actual process and everything, and that is giving you the real time, not real time, but the simulated values on your software. That is about the simulation, again the training simulator. If you want live value, you can pull through the OPC as Shriram, or I don't know, Rajesh, you have only mentioned, and you can pull the values from the OPC connector, and you can feed those value as an input to your simulator software, so that now you can compare real time values in the of the plant and the simulated values in my simulator. Yeah. These use cases you can build, and it is very much useful. Rajesh, Honeywell has already started working on it. They are delivered such kind of projects as well, as I remember. Yeah. Further,
Thank
if
you.
you want some lead, that who is the person who is leading those projects and who can further educate you on these things, I can help you on that, Rajesh. So the exact person who
Yeah,
can
thank you.
do these
Thank you.
things and everything, that thing I can do, Rajesh. Yeah.
Thank you.
And yeah. Any more questions, guys? No? Perfect. So let's. Hmm. In fact, Rajesh, again continue. We will continue for some three, 4 more minutes. Uh, Building this thing or building this particular, if you want, if the plant is small, if you want to, simulate a small equipment only, we can do these things into the Unisim, into the Excel as well. This Excel can be attached as well to the Unisim. Further, you can introduce those thermodynamic calculation in the Microsoft Excel, and you can build it. Of course, it is not that much visual friendly or user friendly, but you can build those small things into the Excel as well. Yeah, I will stop. Continue for the next topic. So now the deployment cycle. Now when we are saying this deployment cycle, it is now I will more focus on the digital twin in context of the predictive maintenance, how the deployments will be, what are the problems in the deployment, and what are the real challenges which we face and how we overcome over those deployment. Those things I will share. And again, just keep on raising the question and interrupt me wherever you want. So yes, the first problem, as you people said, the data collection. As the industry is our, either chemical or whatever, the manufacturing industry is the growing industry. The earlier approach of the designing of the plant was like to keep, of course, again, it is minimum investment based. Minimum instruments we should have, minimum expenditure based designing plant design was there. So the data which is generating from the equipment for doing the predictions or pattern recognition or whatever, it is currently limited. So first problem which we have faced when we were delivering this digital twin or predictive maintenance model, plus the visualization thing, was the data collection. And data collection in terms of whatever real-time values which instruments are showing in the plant and whatever I'm receiving. So that data collection is the challenge. The second thing is the sensor availabilities. Like for example, if I'm having one compressor and I'm doing now I'm sharing the the real example, that we were having one compressor where the different on the NDE side, DE side, the vibration meter, temperature meter, the instruments were available. We used to take data of those instruments for that compressor. We used to train our machine learning models to get the prediction of those values, and it was working well and everything. In parallel to that, if the plant is older, which is having less instruments available for this monitoring and all, or the data collection, so I'm having only four instrument, which is one is showing the temperature and pressure and vibration if required. So if I'm not having the data, the machine learning model will not be trained properly to give the predictions. Okay, so if I'm not having the data, then my predictions will be not accurate. If I'm having more data, then my prediction will be accurate, because of course it is, everything is depending on the data points which are available. So that's why this sensor availability is a major key challenge which we were facing when we were delivering the predictive maintenance project. So that is one thing. Nowadays there are IoT devices are available where you can just fix those devices on the equipment and you can readily take the data within half an hour after the installations and everything. So this challenge is a little bit overcome, but still yes, in the petrochemical industry and oil and gas industry, and typically the old manufacturing setup, this problem is there of the sensor availability and all. And how this problem will affect, that will also I will explain. Yeah. Now again, as I mentioned, data collection and the modeling and also, when I say modeling, it is about the pattern recognition as well. It is about the Unisim design modeling as well. Yeah, and the thermodynamics modeling as well. Yeah, so and the challenge is the data unavailability. Now
Chetan, can I
deployments.
disturb you here?
Yes, you can keep on disturbing, Rajesh. Yeah.
Yeah, this IoT, can you just more
Yes.
describe about it? What type of
Yes.
sensors?
Right.
What we understand,
So,
pressure, temperature,
hmm, hmm.
sensors generally.
Yes, exactly. So usually in our plant, we were having the manual, not manual, but the pressure gauges, temperature gauges and everything, which are not, which are, where the shift operator goes and he will just write the value and he come back. So this is how the cycle of the actual chemical or the process plant. What these IoT devices do, these IoT devices are Arduino based, MQTT protocol based industry 4 devices, which which is a combination of your transmitter as well as this whole assembly, the Arduino and Raspberry Pi and everything. And you it is just a small assembly like a Bisleri ka, the small bottle is like 10 rupees bottle. So that kind of software with some attachment, either a what you can say, either a magnet or something to stick on the my equipment, that kind of assembly there with the battery and all, and you just put that put that instrument wherever you want to measure either vibration of that particular equipment or the temperature of that particular equipment, or whatever you have you are interested in. You just put those transmitters there, the IoT devices there, and these IoT devices used to read the data, and then it used to send it to the cloud where this device is hosted. And you can directly, if you want to see it, those readings on your mobile, you can see it. If you want to see it on your laptop, you can see it. So based on the MQTT protocol, those used to send the values, and the what you can say, the reliability of having this value is more. Why? Because they used to have the storage space as well. So if the network is poor or something, they used to hold the data, and then when the network is good, they used to transmit the data. So that is how these sensors are there. The challenges which we are currently facing with these sensors are like, these are battery based. If the network is poor, then draining of the battery is one major challenge. So you used to keep on changing the battery. If you are giving the electric supply, then yeah, it is good. Second thing is the environment. So our normal transmitters are built to work into the any harsh environment and everything. But these IoT devices, which I have witnessed, are not yet that much harsh environment friendly. So delicacy is one of the problem which we have faced with the devices. But it is great. It is, it is directly eliminating the wiring and everything required for the plant. The maintenance is less because it is just attach and have your values in half an hour kind of devices. Yes, and it is very cutting edge new technology which is grabbing the market now. Yeah.
So
Further in
suppose
my,
if you
yes, Rajesh. Yeah. Tell me.
if you want to measure pressure in a vessel,
Yes.
so it is inside parameter.
Correct.
How
Depends.
this
Now,
can measure correct pressure?
yes.
Temperature it is okay
Exactly.
because it can sense shell temperature.
Correct. So yes, it is challenge. I don't know if there is any such kind of IoT devices as available in the market or not. I will do research on this because I know a couple of the people who are producing these IoT devices, and I will let you know, Rajesh, whether the inside temperature, inside pressure has been they are able to measure it or not. I am not very sure about it, Rajesh. Yeah, but definitely,
Oh,
as the
thank you.
requirement is there in the market, the technology will evolve definitely for that, because yeah.
Okay, thank you.
Yeah. But I will get back to you on this, Rajesh. Yeah. The next use case about it in my current organization, what we were exploring, as the plant has been already set up, we are having the Siemens PLCs already in picture in our existing plant, and we now want to implement our Industry 4 softwares, or the softwares for the end users now. What we were thinking, rather than having the data from normal SQL database, or from the PLC to our on-premise device, and then to the whatever the endpoint, what we are thinking, we are planning to use to make these PLCs as a MQTT PLCs, so that this PLC will directly send data into cloud, and we can use those data into ours is Azure cloud. So in Azure, we can utilize that data. In that cloud, we will deploy our softwares. So that we are exploring now. uh, yes, we may face challenge, but this has been tested. So we have already did the POC, the proof of concept about it. We have made one PLC as a transmitting device. So here we are directly bypassing all the wiring, Modbus wiring, and everything required for collecting the data from the PLC, and the hardware which are required at the plant is also bypassed. So everything which is happen now will in the cloud. So that one use case currently we are exploring, and maybe in coming 3 months we will do the whole plant as a MQT. If the things went well, then everything or every PLC can be called as IoT or the MQTT PLC. Yeah. So yes, one more pause here. If anyone has some questions or something. As we are talking on this digital twin, I will just slightly shift our focus from this chemical engineering or the manufacturing thing. I will give you one real example what is the digital twin which I have faced in 2020. So but before that, yes, again, just anyone have some question or something? Okay, silence means no. Continuing this IoT thing, now I'm exploring one real life IoT just for my learning as well. That how these things are actually working and everything. I'm exploring for one project. If any one of you, either student person or from the industry, is interested, then let's collaborate and build that device, which will be helpful for us. So just reach out to me. Yeah, if you're interested with your time, we have funding and everything. Just reach out to me if you're interested in building this device. Yeah, that is one disclaimer. Yeah, perfect. So moving ahead, now there is one interesting case. When in around 2020, when I decided to move from the Honeywell, and it was a kind of big move for me, because when you are working for 10 years for in one organization, then it's like family for you, and when you are switching from that, it is totally different. When you are working for 10 years for same people, for same organization, on same product and everything. So I started, and I was behind the industry, as working in the same thing for 10 years. So I started exploring multiple option. I have met one very interesting guy who is from the Cognizant, whose name is Milind Chitambar. Just write down the name and explore his profile. He was ex-Cognizant. He was at the director level in 2015 in Cognizant. Extremely techie guy. Worked in the Silicon Valley as well. And then out of the curiosity, as he's having the background of the what you can say, the astrology and all, he combined the astrological knowledge which we are having earlier in the books and all with this machine learning, and he started predicting based on your date of birth your future. Okay, so his customers are like person like me who want to know about their future and everything, and he used to combine the technology, and he already made the software which will predict based on my date of birth what my future will look like. And in 2021 somewhere I met him. Our plan was to meet for 1 hour, but that meeting has went for almost 6 hours, because our interests were matching and the things which we have shared. Okay, the future predictions are the different thing, but things which how the clones are made, how he made these clones and everything, that things he have shared. And the surprising part was, and why I have attracted toward this machine learning and predictions and all these things, was he gave me the prediction, and those predictions were uh, 99% true. He predicted my date of joining in my new organization, which was plus or minus 2 days only. The error was very less. And from that day, the things which were happening, are very much aligned with the prediction what he have done. So I did that whole entire 1 year, one hours recording as well in my mobile. That mean for how my next 20 years will look like. So that is also one of the case. So I kept on discussing with him that this is the digital twin only, how you are doing this thing, what are the technologies and everything and everything. So it is very interesting example of the digital twin. Okay. And right now as well, the things are which are happening, my recent joins and everything are in between those regions only. So direction is he have already predicted that direction, and direction was right. Those predictions were also right. So his model is perfect. And yeah, that's it. Again, I'm just reiterating his name, Milinda Chitambar. You should definitely visit to his page, his entire profile as well. Yeah, it's very interesting. Sorry, just a little bit diversion from our actual digital twin, but this is also digital twin. Yeah. Further, one more pause if you have some curious or interesting questions. So Ramesh sir and Neeta ma'am, ये जो ऐसे session है ना, this should be in person. Then it will be more interactive or whatever. It's my
Definitely, sir.
suggestion. Means you can. Yeah.
Definitely, sir. We
Yeah.
will put in the in session offline in the next
Yeah,
time.
right.
Okay.
Right.
Okay.
Yeah. Yeah. Perfect.
So,
Any
Chetan,
questions,
one
guys?
question here.
Yes, Mayuresh. Yeah.
Rajesh here. Yeah. You said Mr. Milind Chidambaram predicting this astrology.
Your
But
voice
what
getting
you
good.
understand, it is all astronomy related. So, what is the science behind it? Means
Yes,
from
science
where,
behind
what
it.
first laws
Yes.
of science? What is the connection
Ah.
between that?
Connection between that
Was it
is
explored?
yes,
Just out
definitely,
of
because
curiosity, I want
yes,
to know. It is not
yeah,
related to this.
no, Rajesh, this is very right. This, see, I went to meet him for the
Because
1 hour
what we
only.
understand, this all planets, it affects human lives
Correct.
because we are 80% water.
Exactly.
Okay. So
Exactly.
the basic fundamental laws, okay,
Correct.
where that were explored.
Yes. Yeah. So yes, to answer this, Rajesh. So your question is why I am accepting or why I'm very happy to have this question, because I went to meet that guy for 1 hour only, but this curiosity has stretched for the 6 hour, and because of the curiosity only. Okay. So yes, curiosity is always welcome. You can ask anything what you have in mind. That is first thing. The another thing, uh, depend on the position of the planet, and on those position what is happening in the world. Okay, based on those correlations he have generated, because whenever we took the birth, the planet position is different for all the people. Okay, so based on those correlation he have done his predictions. Okay, again, what are the algorithms are used, that went beyond my understanding, or my अवकाश से ऊपर था वो, but that is the thing which he have used in his prediction. The another example what you said is, there is one more software, shunya investment करके, they are predicting the share market moves based on the different multiple factors in industry, plus the one factor which they are using in their machine learning algorithm is the moon's position, right? From the full moon night to the no moon night, जो transition होता है, in no moon night people used to take more aggressive actions. So उनके जो prediction था for their share market algorithm, and that is running software, and the person who has developed that software is the ex Honeywell. So he said that he have considered one factor of the position of the moon as well. So that is how these things are affecting. Yeah.
Okay, thank you.
Yeah, I'm not sure whether I'm answering it logically, but this is the thing which is, in fact, we can have one call with that person as well. He can explain in detail, either with Milind or the one who have developed this शून्य. मैं ऐसी चीजों में बहुत हूँ. Just again because of the curiosity.
Yes, thank you.
Yeah. Guys, any more questions? Okay, again, continuing this discussion, there is one, you can just write down these names. There is one person, Aniruddha Joshi, Dr. Aniruddha Joshi. He's very well-known chemical engineer. He have his startup in the Hinjawadi, and his startup name is Nadi Tarangini. In Nadi Tarangini, what they people do, they have these IoT devices or the smart watches where they used to where they keep on observing our Nadi vibrations, and based on that, they used to predict your health problems. So watch अपना हमेशा रहेगा, the nadi will keep on vibrating. I don't know what they call it in Ayurveda terms, but this nadi vibration they used to observe, and based on that they developed the algorithm where they can predict the problems in your health. See how the technology is going, and this startup is very amazing. It is founded by the chemical, his father is also, I just forget his father's name, but he's also very well known in the chemical engineering. He's also doctorate person. Yeah, maybe any one of you, if you know, have ever heard about it, you can just mention it. Yeah. So the name is Nadi Tarangini. The person is Dr. Aniruddha Joshi. Yeah. Yes. Anybody? Any questions or something?
Is that
This is going
software is
interesting.
available? Hello, sir.
Yes,
Chetan
Ravindra.
sir.
Mhm.
Is that software is available? What you say, the Nadi Taranga, or
No,
they?
not a software. Why? Because that software is their bread and butter. But those devices which you we used to, monitor the smartwatches or something,
uh,
those were available for sale. So that is their model, financial model. Yeah.
Okay, okay.
Further, if you are interested in one more call, we can arrange with this Nadi Terangini person. Actually, I am planning to visit their startup, that how the things are doing. They have recruited some Ayurvedic doctors as well, so the BMS doctor, plus the data scientist, of course, and that is how I am came to, in that network. So, and if you are in Pune sometime, and if you want to come along with me to visit that startup to talk with that genius guy, then we can definitely go. Yeah. At last of my presentation, I have mentioned my name, so we can just collaborate and we can go there. Yeah.
Definitely, definitely, sir. We will visit.
Yes. 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 Sure. So yes, I will just take a water for a minute. Yeah, continuing our topic. Anita ma'am, just मतलब कहीं पे divert अगर हो रहा है, you can just stop me. Anita ma'am or Ramesh, anyone. Yeah.
It's interesting.
Yeah, it's really interesting. Yeah, in last month I have conducted one get together or one session where all the digital people from Pune, they just come along, talk right from the fresher to the CIO level person. We have just sat together and we discussed randomly the things, that how much we can help each other and everything. Some people want the growth in their career. Some people want to switch their career. Some startup owner want the, what you can say, the orders or something, or to the leads for lead for increasing their business. Some end user want to explore the product. So just sit across the table. We were around 70 people. We exchange a lot of information for almost 3 hours. We were talking with each other. It was a networking kind of event where this such interesting and new idea comes from the surface. Yeah, perfect. Getting back to our actual topic.
Yeah.
So
So Chetan, though it sounds very interesting, right now we have a limited time, so
exactly,
it would
exactly.
be better if
Yes,
we get
yes.
back to that.
For from my side, yes, I am available. But you people, yes, of course, I should respect your time. And we have only, I guess, 60 minutes more now. Let's go
Yeah.
back to the digital twin. Yeah, because yes, further there are many more interesting things in the next slide as well. So yes, the challenges each equipment have, different patterns, templatization. So this is one more challenge. Uh, each equipment in the industry, each wall, each vessel, reactor, they behave differently. And when I say what I mean by the behavior is, when if you compare with the to simplify this thing, if
Thank you.
you if we want to compare with the actual human, yes, though we have, all the sensors same, eyes and nose and everything, but still our response to any anomaly or anything which is, different from the normal thing is different from person to person. Likewise, the equipment, they have their different pattern. for each and every what you can say for each and every algorithm, I can say. And that is also one challenge, because we cannot predict or we cannot templatize these results. So we have to study each and every equipment in their context, like reactor 1, reactor 2, though their design is same. We need to take data from them. We need to train our machine learning models so that they can give the actual results. So this is one of the challenge where we need to continuously train our model for the, and in the 6 months as well, or the iterations of this recognitions have to be more to get the good predictions and the results. So this is one challenge which take the time, of course. Now, yes, monitoring. So yes, everything is ready. Our digital twin model is ready. Each and every equipment is properly. We reach to the patterns. We have recognized the patterns. We have prepared the rules based out the patterns. What should be the outcome of that particular anomaly if something has happened? What things should be raised? There is a team which should keep continuously monitoring all those equipment, so that if the anomaly is going to happen, the alerts which are raised by the system should be conveyed to the operator or maintenance people or whatever it is. The next challenge is the false alarm. If I did very good machine learning, if I did very good pattern recognition, my predictions are also good, the things are going well, but if some instrument is malfunctioned, so suddenly my temperature is showing zero value, and yes, my model will not understand that what is happening, and it will raise the false alarm that my particular equipment, though my ambience temperature is 25 to 30, my temperature is showing zero. So it means something has happened, and then my equipment will raise alarm, and then we need to show it. So this is of course the false alarm, which is not the actual situation, but my model will recognize this as a, or my digital twin will recognize as that something bad is happening. So this false alarm is currently one challenge in these predictions or digital twin models which we are facing currently. So that is about the challenges into the deployment cycle. Next now, what are the industry prospects? How the industry is doing these things and everything. Now, typically, I have witnessed about the Honeywell, where I have actually worked on it. I have talked with the Aviva guys. I have talked with the Yokogawa guys. I have met this digital twin by my hand in the Excel as well, in for the IG petrochemical. So, what are the industry factors? How prospect? How the industry or the how the service provider will go doing this thing. So first thing is the product design. So before physical prototype or before actually working on that particular digital twin thing, first we will collect the data, just the old 2 years data. We will build our model. So before anything which is happening, we should first design the templatized approach first, right? For particular compressor or steam turbine, that matter, which instruments value we should read, combining those value, what are the outcomes which we expect from these things. This everything should be discussed with the subject matter expert, with the person who is designing or the developing this data science or the machine learning model. Those things should be already considered into my product design or the digital twin design, I can say. Yes, now product optimization, then identifying insufficiency, inefficiencies, and optimizing the resources. And when I say that, the basic problem which I have highlighted, that availability of the data or the instrument, all these things, this has to be already taken care. If I'm not able to get the data, if this data is not available for 1 minute or for half an hour or for half a day, what should be my fallout or rollout plan? Those should be already identified based on the earlier experience and everything. And how, whether we don't have that for the one data for the one instrument, whether we will just extrapolate the data, or we will manually collect the data and we'll fill it, or that instrument itself will, if it is IoT device, hold the data for half an hour and then it will release the data. All these strategies must be planned before doing this digital twin exercise. So that is, I called it as a time or product optimization. Yeah, predictive maintenance, the whole lot thing I have talked about. Now, where we can use this more as a supply chain management to simulate supply chain dynamics. Now, how? Just one example is like, if we have fit the what you can say, location devices, identifying location devices in the truck. If your supply chain is big, then you can directly know how much your fuel consumption, where your material exactly is, how much your material you are transporting, how you can optimize those materials. These everything can be accommodated in supply chain management. We have already couple of use cases which we are developing, which we are deploying in our current organization. In my earlier organizations, we have also witnessed this supply chain management use cases for my for the predict- uh, prediction thing. Just one example here I want to share. Looking at the limited time, currently what we are doing in my organization, the production. So this is a batch manufacturing where we used to produce the paint on our line. There are 7 different lines. We continue where continuously the paint is getting poured into the boxes getting lid and everything, and by robotics this getting packed. So those kind of processes were there. There are total 32 tanks. From that tanks, the combination of color or the depending on the quality which we require is used to come and getting poured into that particular can or something, can or tin or whatever the production requirement is. So to optimize, how now we are doing, depending on the forecasting. Now here when I say forecasting, the sales forecasting in my next 6 months, in my next 3 months, in my next 1 month, in my next 1 week, what exactly paint is required in the market. Now, how this exactly paint is required for my next week is getting calculated. Again, there are different algorithm based on my last year's data of this consumption. Based on the data, I'm used to predicting in this year, in this month, in this week, what amount of paint I will require. Now, if we just start imagining, now if we have Diwali, and in Diwali my particular because we used to do the cleaning and everything and coloring to our house and everything, so the prediction is more, the requirement of the paint is more in my Diwali time. And when exactly? Before couple of week of Diwali. So my prediction model or my supply chain model will predict in my next year when the Diwali comes, this requirement of the paint will be more. Okay, that is how this engine will run, and this will go to my salesperson. That in particular, again, now Diwali is in mostly celebrated in the middle of India or north south of India, less in the south side of India. Okay, so the salesperson will get this prediction like in south there will be not much paint production will be required, but in the middle of the India and at the north side, the paint requirement will be more, and that data will be consolidated and will go to the production person. And based on that production, okay, this is my last year quantity. Now you decide your plan of the production of the producing the color, and then do your planning. Okay, that is how this recognition or the data science models will run for predicting your requirement to the predicting your production. And now based on this production, okay, in my next week my production will be this much paint will be required. Based on that, the information will go to the planner who is planning which color to be produced on which line. Now based on this line's performance, the decision will be taken by the planner. So planner will have in his hand this much we need to produce. We need to produce 1 ton of paint. For producing that 1 ton of 10, now you need to manage how this your lines will run. The OE, if you know this concept, the overall equipment effectiveness for my particular line is this much, then that planner will give that much paint production target to that particular line, and then that line will do. And ultimately all result that okay, I want in this particular week the predicted target of the engine was like I need to make 1 ton of paint, but only I was able to produce zero point 0.8 ton of paint only. So this again back calculation, why this difference is there. Now So the again those root cause analysis will be done through the supply chain team, and then further this model will be trained based on this. Okay, I need 1 ton, but my system is able to produce only zero point 0.2 ton, zero point 0.8 ton only. Then what are the problem and everything, and then people take action on that, and then further things will go on. And these all inputs will go to the your prediction model. The production model will calculate or recalculate themselves for giving the better result at the next time. So this kind of thing is comes under the supply chain management. There is one interesting use case which is shared by my sister-in-law with me. He was working for the Infosys in 2018-19. Their project was about the Pepsi, the cold drink, Pepsi cold drink, and they were serving for the US client. The prediction which used to give by them is for particular my store, how much the cold drink requirement is there, that has to be ready with the store owner prior to the day. So tomorrow your store will require that much this much of cold drink. That prediction has to be with the that store manager before the day. Why? Because he will manage that much inventory only in his store. So that kind of accuracy these people used to maintain in 2021, I guess 20 in itself. So that is one of the interesting use case I went through discussing on it, and then I used to explore many other things. It was kind of very big project it was. So that is one use case was there for the supply chain management. Again, moving next to the quality control. Sorry, I'm little bit
So
moving here and
Chetan,
there.
sorry to interrupt you. I just got confused. Whatever app, the perspective you're giving, the paint example or this
Yes.
example, how is this like digital twin is coming
Yes,
coming
yes.
in?
Yes, Nida ma'am. So again, when you are saying digital twin, this is not about the chemical process only. This is about the supply chain only. This is about your production plant, your production line as well. So if you are considering, so when I am giving the example of the plant or the batch process, my line, so I am doing the digital twin of that particular line. How much this line can produce? Okay, that if I know, then I can plan my production accordingly. Okay, if that line is producing less, and how I know that this particular line is producing less, because I am having the earlier information, earlier data available with me, that this particular line having only this much of OE. So I will plan my production accordingly, relying on that particular line. If the OE is more, okay, then I can have more production plan on that particular line. As I am having different 7 lines and I want to produce this much of blend, as a planner, as a production planner, I having this knowledge beforehand with me, how much I want to produce and how much the capacity of each line is helpful to give me the optimized result. So that is one example which is related more to the digital twin thing. Yeah. Is I'm clear or?
Yeah.
Yeah. Perfect. So, yeah, see, till the time, how this digital twin has been saw by the system or the service provider is like only give the simulation or give the some predictive maintenance program, and that we call it as a digital twin only. But if you see the holistic view, because I am the person who sit as a customer as well as a service provider as well, how these predictions can be used for the entire this value chain, right from the having your raw material in your factory to the end user who is utilizing your product. So yes, there are multiple use cases, and systems are dependent on each other. So yes, now how we are using this digital twin in my what you can say, the manufacturing industry for the renewable is like we used to introduce one product where it is permit to work, just a simple software product, no machine learning, nothing about it, but the data which is generating from this permit to work, how we utilize it as a digital twin. That example I will give you. This permit to work are used to designed to first as a compliance, when your operator will go to any plant or any turbine, he used to submit this permit to his manager. He will approve the permit, and then the material requirement or whatever, it will come back to him as a approval, and he will go on that he will uh, go to the maintenance shop, he will take the tools, he will do his work, and then he will come back. That is how the thing is. Okay, so so these operators or the people who are field operators, they used to generate these permits and they used to work in the plant. So we have across the India, we have 250 sites, more than 250 site, and they used to issue this permit to work, and they used to do daily. Now, based on this data, what insights which we have generated, that my particular machine is failing again and again, and how we got to know my particular operator is going to repair continuously raising the permit to work on that particular machine's particular part. Okay, so this insight will be ready with me now, that my particular machine is failing. Now, having observation or making the digital twin of that particular machine, extracting the various parameter, will help me to predict either the failure of that machine. The second thing is to take the corrective action, whether I should take the corrective action or that machine or not. Third thing, whether I should replace that machine with another thing. Okay, so this will help me to take the proper business decision. Okay, and again, why I'm calling, I will call this as a digital twin, because I started recognizing the pattern of that machine. Okay, this machine is failing after each 15 days or 30 days or whatever it is. Okay, based on that, I will plan my preventive maintenance activities on that particular machine. So yes, that is also one example. Phew. Next, now quality control. So real-time monitoring, of course, then QC lab and everything. If we can, so currently we are doing one project where we are digitalizing our quality control lab for the real time monitoring and everything. As we are in paint manufacturing, having the good quality and everything is our most main priority. So each and every lab equipment we are continuously monitoring, plus of course the predictive maintenance of those equipment, because this machinery is very costly and everything. So these are also one of the industry prospect of this whole value chain. One more pause for your question, guys. Tired of talking now, so just 5 minutes pause. Please reflect on your questions. Rajesh ji, Shriram, anyone?
Chetan, can you provide any example of process equipment
Yes.
actually for of digital twin? If it is too complicated, you can give milestone in development of digital twin. Most of us are chemical engineers.
Yes. So yes, we'll go in example. It's
Yeah.
what equipment you want, because I worked for many equipments for their digital twin. So you suggest what equipment you want, and I can give you step by step approach how you can do this digital twin in the Excel as well, how you want to do in your Python as well, or whatever it is. Just give me the example of equipment, or and we can go ahead with that example, and I will just break down in each and every steps and everything. Yeah.
Any digital twin model that you may be having.
Perfect. Perfect. So yeah,
Separator,
I will
pump,
choose then in
reactor,
that case.
compressor.
Correct. So let's go ahead with the compressor. So if you take the example of the compressor, then yeah, for the compressor, there are the different type of instruments are attached to the compressor to have either to operate a compressor, that is first thing, or to have the view, or on the HMI you should see the values, how this compressor is operating in the normal real time and everything. For that visualization, there are different instruments are attached, right from the driving end side of that particular compressor, for the seal what you can say, the sealing material and all these things, to the lube oil, to monitoring the lube oil temperature of that compressor, because it is industrial compressor. These instruments are there, which instruments are ranges from the temperature instruments, from the vibration instrument, because the vibrations are important, the axial vibration, axial displacement, the rotations of those particular compressor. All these things are continuously monitored on the DCS, plus historian used to save that data. Now, as a digital twin, if I want to imply that, or if I want to deploy that compressor model, what I will do first thing is I will collect this data of each and every instrument. So typically, if you take only compressor example, there are 12 to 14 instrument data. I will collect that data for 2 years. It's a normal time frame, because 2 years will mostly 2 years will cover all the temperature patterns in the environment, plus the shutdown pattern, like startup and shutdown of that plant. I will collect data for this 14 12 parameters for each 5 minutes to 10 minutes gap. So this historian parameters, so I will have the time series data for compressor, where each temperature, pressure, flow, vibration, everything will be available for each time step of 5 minutes. So that is the data collection first thing. Okay, I will have this data for 2 year. Now I will do the cleaning of the data. And when I say cleaning, what I mean by the cleaning is sometimes the temperature showing by some instrument, if that instrument is getting failed, then this is showing something abrupt temperature, then I should remove that data. Okay, so the time series data with the actual process parameter will be available with me. If some vibration is showing some 50 value, just remove that data and clean the data, so that the actual running parameter, the real values which are in the physical system and which are with your instrument will match. So that data will be available with me. That data will be clean. And now based on this clean data, I will prepare how much these parameters are depend on each other. Like for example, if my temperature is something 30 degrees Celsius for particular, so currently it is 12, 15, 51. So at 1 o'clock, my temperature is this much, my flow is this much, my vibration is this much, and particular things are there for particular time step. Okay, this data will be available. I will generate the pattern amongst this data. If something bad is happened or some process is disturbed, then how these patterns are changing, how the correlations between these each parameters are changing with each other. I will generate those algorithms. I will take a pause. If you have some questions, Rajesh, ask me here, so that further I will dig down to this process.
Yeah, no, please continue.
Perfect. Data collected, data cleansed, patterns will be generated. Okay. Now, based on this pattern will be implemented in my software. Okay. Whatever the software is, either it is Honeywell, Aviva, or whatever, who some startup is there, those algorithms were already introduced. Now, my this compressor is keep on running, and these patterns were already fed. These machine learning algorithms are already fed to my software. Now based on those algorithm, if something bad or something discontinued, something, some process anomaly has happened, then my current software will compare with my existing algorithm whether this thing is happening. Now when I say this thing is happening, mean by that, for my particular flow of 15 meter cube per hour, my temperature is this much, my pressure is this much, my vibration is this much for particular flow. Now the flow is little bit varied, and the temperature and all the parameters are little bit varied. That is okay, that is into the within limit. It was happened in the past as well. That is understood by my software. Now if my flow is constant, my temperature is in okay range, like 35 60 degrees something, whatever it is, but the vibration is something more which was never happened before. Okay, so this is something which is going beyond normal patterns. Then my digital twin will directly say me that, okay, for this flow and for this flow, this vibration is something which is not matching, this pattern is something which is different, so I should raise the alarm that this vibration is not proper. That means something is going to happen for my particular equipment, you should take action. So that is the whole concept. I will again take a pause for your reflection, Rajesh. Is my explanation
Yeah.
was clear?
Yes. Thank you.
Perfect. So this is how this machine learning or pattern recognition algorithms were generated, and this is how the anomaly is generated out of the software. That this is something which is not proper. This is something not new normal or normal. Okay. And why I am saying that iteration of these iterations of these recognitions or pattern recognition model or algorithms are required, because after each 3 months the behavior of that particular equipment is getting changed or the process changed. So to learn these new algorithms, because my algorithms are 3 months old, okay, it may not give the same result after 6 months. Okay, So we should keep on, retraining our models for giving the correct predictions. So yeah, that is one example. Okay, now here we are giving the prediction, and the system will generate the anomaly. Okay, Chetan, as your operator or the maintenance person, this something vibration which is going off, which is not correct. Then my software itself will take that signal, and it will give me based on my what you can say root cause analysis diagram or something, that if my vibration is particularly not correct, then Chetan go and check the sealant whether it is leaking or not. So that is the prescription which is suggested me by my software only. So here my job will be reduced. That how the job will be reduced, that having this knowledge of something is going off and having continuously monitoring that, rather the system is directly giving me the prescription that Chetan, as a maintenance person, you should go and look this system, something is odd. Okay, so that is we called it as a prescription based predictive maintenance. Its concept is the explanation was clear, Rajesh, or should I further dig down to it?
Oh, thank you. Thank you.
Yeah. Yeah. Any other person you have any doubt in this thing or something has how it is happening or something? And again, now the example which I gave to you is about the compressor. So here, if you link the concept with the compressor, there is nothing process related which is the so if you take this for 14 instrument and if you put on the heat exchanger, same thing will happen. Only what will change, the behavior of this parameter or the dependency of this parameter will change on each other. So having compressor there or not having compressor there, having different pump there, it doesn't make any difference. Is this concept is clear? If those 40 different instrument has attached on my body, then also this 14 instrument will generate a data. Then also my machine or my Python algorithm will generate the patterns. Okay. And then there you can make this digital twin as my digital twin. Things are clear, guys. So here there is nothing which is contributing from the physical system, or nothing is which is contributing from the first the thermodynamics first law. Okay, it is purely about the data and the algorithms and the machine learning and all. When I used to when I took this data and input, I will put it in your Unisim engine. That time the chemical process equipment process parameters will come in picture. My Unisim will do the thermodynamics calculation, but this predictive maintenance will never touch to the thermodynamics. It is direct, it is actually generating data only, or actually generating the prediction only based on the data points, what you can say, or the numbers rather than the thermodynamics. Is this differentiation was clear? Silence means yes or no, I don't know. It is bit, kind of very a typical concept. Usually usually these things were not clear as I was working on both the things, and I have designed those models, I have prepared those predictions as well. So that's why I know this difference. So again, it may be heavy. Rajesh ji, if you have some doubt, we can
Yes,
directly
yes.
connect on call and I can explain you. Yeah, I
No,
hope
you
it
can
is.
proceed. You can proceed.
Yes, perfect, perfect. So now, yes, use cases in the industry. Recently, just before a minute, I have explained for the rotating equipment. So when I say rotating equipment, I will take one more example here. So digital twin of my particular pump. If I build that pump in the Unisim and if I give the flow parameter, the chemical composition, whether the water flowing through it or some aromatic material flowing through it or some alcohol flowing through it, then it will behave when it is in Unisim. It will behave on based on the thermodynamics law and principle. If this particular pump instrument only I'm taking the instrument values data, time series data, and I'm generating the machine learning algorithm and predicting the values or the anomalies based on that, then that will have nothing to do with my thermodynamics. It is purely based on the data, the predictions, and the learning algorithms on pattern recognitions. Yeah. This is for the rotary equipment. Now for the batch monitoring and optimization, yes, how the visualization will be there based on the so if my batch is particular batch is running for the 8 hours, the ideal time is 8 hour. Now based on the data points and everything, I can close that batch into the 7.5 hours. And if the quality is good, now my next new normal of that production of that batch, of that data for the monitoring, it will be 7.5 hours. If my next batch is running for 8.5 hours, then as a operator or as a maintenance person, I should be looking after it where I'm losing the time and everything. So that is one more example of the digital twin. Honeywell has already built one product around it for this batch monitoring and all. I forgot the name of that particular product. Now, again, for the automotive industry, just in last week, I visited Volkswagen where they have uh, discussing of the including this digital twin for a particular one line where they can monitor the OE, which I have explained for them for my overall equipment effectiveness and everything for my particular organization in for print monitoring parallels. The same concept they are exploring for their production line. Healthcare use cases, yes, of course. If you compare the same example which I am giving to you in the oil and gas, for the equipments, yes, there are predictive maintenance things which we can build on this healthcare industry. That is one example of the digital twin. Again, the thermodynamics based model we can build as a use case for this healthcare industry. Further in healthcare industry for the formulations and all, we can use this model like in my okay, anyways, I will not more it's already we have 30 minutes only, so I will not take much time on the examples and all. Sustainability, of course, if you compare with the as current trends are going towards sustainability and all, if you are so what we used to present is like how we are supporting the sustainability, that we are predicting if some equipment is going to fail and we are saving the cost or saving the fuel for that particular failure and all, and that is how we are saving the environment, that is how we are supporting the sustainability and all. So that can be use case which we can present for the sustainability. And training simulator, of course. Now, yes, conclusion. Consideration while investing in digital twin. First thing, why digital twin is required or not. That is first consideration should be done. Now, which approach you want to take, whether you want to go to the thermodynamics way, whether you want to go to the digital twin way or the predictive maintenance or the pattern recognition way, or you just want to visualize whatever you are happening in your plant. And this is the real cases which industry is looking after. Okay, those consideration should be done while investing in the digital twin. What is the benefit I'm going getting out of it? Those things should be considered. You should be ready with your data and sensor readiness, because if your system is just a on ground system and it is having no digital footprint, you cannot collect your data from your system, then there will be no digital twin for the system. So those readiness should be considered. The strategic importance of the digital twin is important to stay competitive in the evolving manufacturing landscape. With that word, we used to, or the service provider used to, impress the end user that you should buy our software. Why? Because you have to be stay competitive in the evolving manufacturing landscape and all and everything. But yes, of course, the end user should definitely think about the ROI on the whatever investment he's doing into that software, whether it is really giving the value out of it or not. Those things are considered. Now, yes, first thing, is this a practical solution or just a hype of technology? Again, depends what you want out of that system. So if you are in oil and gas industry, if you are operating a plant, then having the operator who is already trained on the simulator is a good thing. Why? Because he will not burn out the plant, he will not do the production losses, and production losses is kind of something which is hampering this oil and gas industry very much. So, but if you are operating one small batch process plant and you are bringing digital twin technology with all the predictions and all everything to that plant, it is not useful. Okay, so those intelligence question end user or service providers or the manufacturing, they ask to their self, they should evaluate the outcome which are promised by the service provider, and then only go for this technology. As I always say, this digital twin, predictive maintenance, pattern recognition, everything can be done on the Excel as well. I have did it, I have monitored my solutions on it, and we got good result out of it. So yes, these questions should be asked. ROI, of course, one should ask to everyone, every end user should ask this question to the service providers. Acceptance, now this is the major thing which now we are facing as a digital transformation implementation person. Whether we are bringing this, all the fancy and modern solution are getting accepted by the operators or by the maintenance person or not, whether the people are ready for these new technologies or not. Being a person who used to implement this technology in India, in the US, in the UK market, in the Europe as well, I can say that the resistance from the people is very much. They are not ready to adapt the system. Educating them to utilize this system, and how we can effectively educate these people is by showing the value out of the system. If it is useful for them, they will definitely use this system. So this acceptance also one thing which we should consider while having the digital twin solutions. Technical depth, so having one big software, and after that nobody is there to maintain this software, then it is kind of technical debt for us. So that thing also should be considered, and the criticality of this software. So yeah, so these things one should definitely consider while proposing the solution to anyone, or while doing implementation at their particular system, or while you people are also, when you are thinking about learning about this digital twin, or thinking about learning of the Unisim or whatever it is, you should first analyze the market trend, what is the major requirement thing from the market, and then you should take this decision whether we should go for learning of this particular technology, or I should learn RPA first, or I should learn first the pattern recognition things first, or the data science first. Those decisions should be taken. And as per the slide, that's what I was having on the slide. Now let's take this last 20 minutes for the questionnaire or whatever it is, whatever you have in mind, and let's question each other. Yeah, open for all of you guys now. So yes, uh, Nita ma'am, I hope I have covered the correct things. If not, I'm ready for the another session as well, or in person as well. And yes, guys, please go ahead with all your questions and everything. Over to you now. If the digital twin is topic, I can continue talking for 4 more hours. Yeah, but yes, time is less now. Yes, Mangesh, you are saying something. Is I'm in call, or how? You people are went all silent.
Shall I mention one digital twin application in chemical?
Yeah, definitely, Shriram. Yes. Hello.
I just wanted to give one example of a digital
Participant,
twin.
please ask questions. You can write in the chat box, or you can write in the Q&A section.
Yeah, Shriram, please go ahead with your sharing.
Okay, one such example which I have seen is 21 tank deep treatment, chemical treatment for various auto parts. So
Mhm.
in traditional method, the time and motion chart is pre-prepared, and as per that the process runs.
Correct.
But this is a non-intelligent process. So in this case, suppose tank is skipped or chemical composition changes, concentration changes, then the whole TPM has to be rewritten.
Right.
But if this is run with digital twin, let's say if you have your controller is having facility to run this digital twin, or it could be run externally in another system. In this case, the operator can select the tanks which are need to be put in process or taken out of process.
Correct.
The concentration of chemicals in each tank can be selected, and what is the tank time required can be entered by the operator. Now,
Correct.
this digital twin calculates all these sequences which are to be generated and passes on to the PCS or PLC controller.
Right.
And the system runs as per these new settings.
Correct.
And here there is no
So
intervention.
Chetan,
Only the chemical
I
engineer
always thought,
enters
you know,
the steps.
digital twin is just replicating your plant and, you know, troubleshooting it, or it is, that is what the digital twin is being used for. But you gave a different perspective of digital twin used in other aspects or areas also, which was quite interesting. And as far as some projects are there, our students are, you know, keen on doing it. So if anything is there, we can collaborate and you can take it further.
Definitely.
Yeah,
Definitely.
sure.
Yeah. Shriram, you're still continuing.
You're
right?
not audible. I think you're muted, Chetan.
No, I'm talking. Hello.
Hello, you are audible, sir. No problem.
Yes, yes, I'm
Yeah,
audible.
yeah,
In fact,
yeah.
Shriram was mentioning some case. Shriram, can you please continue? He was sharing some interesting
Yeah,
thing.
that's what that words I was to put up that
Yes.
digital twin enabled inside a smart controller. Nowadays, PLCs are available where they have such AI enabled
Yes.
systems.
Correct.
So
correct,
this
right.
model which is created for chemical treatment can be run in PLC. So it has got both things. One is that design time as well as operation. Both will
Correct.
be handled by the controller.
Great. So here you are making PLC itself as a for prediction or or the recognition machine or smart machine, I can say. Yes.
Correct. New Siemens
Great.
controllers are available with this
Correct.
NP
Correct.
technology.
Right. Great example. Great example, Shriram. Yes. So yes, anybody else, if you have something to share, or yes, so this is my number. I will share this presentation also with you people as well, and so you can just reach out to me, and either we can collaborate on the things or we can further discuss on the things. And Ravindraji, Rajeshji, when I'm visiting this Nadin Tarangini, I will definitely let you know. Just let's be in touch on WhatsApp.
Yes, sir. One.
Yeah.
Anybody having questions? You can post in the chat box also. If there is no question, then I will go for the thanks.
Hello. Hello.
Hello. Huh?
Yes,
One
I
minute.
had a doubt. So as you said, the digital twin uses real-time data for analysis of its dynamic model. So what is the latency of this data receiving? Like, is it within seconds or what is the time range?
Okay. And Mayuresh, then okay, just to understand the context of question, you are from industry or how?
I am a student,
You're a
third year
student.
student.
Wow, third year student should have that question, which is very surprising for me. And for that, congratulations, Nita ma'am and Ravi and Ramesh sir for having such student. So good question, great question rather, Mayuresh. Basically, the digital twin which I have handled, I was having 5 minutes latency. So I'm continuously taking the data from the 5 minute maximum latency is 5 minutes. Yeah. So and I am calling this 5 minutes as much as real time only. Okay, so yes, so 5 minutes latency I was handled. Further, in couple of use cases, we have used for the 10 seconds latency as well, but it is very much system burdening. So that was not went through after the POC. So 1 minute to 5 minutes is the sufficient latency which we have considered yet for the, because the predictions which are given by the system or like after 3 days your system is going to fail. So 5 minutes is a logical thing to have the latency of the system. Yeah. Is the questions answered correctly, Mayuresh, or
Yeah,
anything
yes,
else
sir.
here and there?
No, definitely it answers my question.
Yeah.
Thank you for that.
In fact, Mayuresh, if you are more interested, then I can exactly tell you how this pattern recognition has been done, and you can try this in the Excel without any. If you know the Python and everything, then you can generate it in the Excel as well, so that you will have this basic knowledge that what things are exactly happening, how these algorithms should be written, and how this data is consumed and used. So we can definitely have one
Yes, sir, definitely.
one-to-one session on
I
it.
have an interest in this. And again, as
Yes.
you mentioned about Python and Excel, so
Hmm.
can you throw some light on the requirements of which all languages should I know? Like being a chemical engineer, we don't have that much interest, by the way, I would say, in
Hmm.
such coding languages. But yeah, if I should know what
Yeah.
language it should be.
Yeah. So first thing, being chemical engineer, we should have interest into this Python and everything other things, because this is the thing which is giving more money. Okay. So yes. So definitely everybody should learn the Python to generate the prediction, to generate the patterns. Python is the most required thing. Python and Excel combination will give you all the functionalities, which not all the functionality, but what are the minimum required functionalities for the digital twin. These two combination, and I'm very sure about it because I have already delivered it. Now, if you want to deliver it as a product, then you have some visualization. So this .NET thing, or the Power BI, these things will can give you the visualization. So you can directly show the value, and its a predicted value, the difference and errors and everything. So these are the minimum requirement, I can say, as a data scientist, or the person who is chemical engineer and working as a data analyst or scientist, or the prediction person should have. First thing, Python for data cleaning and everything, pattern recognition, and second thing for the visualization, a least important, but yes, it's good to have knowledge, is the Power BI thing. Yeah. Other thing, the .NET and the React and all are not much required. Why? Because we are definitely, ultimately, we are chemical engineer. We should not be a software engineer to develop that software. And Mayuresh, you should definitely connect me. We'll talk in detail in this.
Yes, sir. Why
Yes,
not?
Rajesh ji.
Yeah, that's all.
Any
It was
question,
very
participants?
informative session.
I hope it is useful. There are many other things as well to share, because I am in touch with other startups where I am supporting the other startup to include more and more feature in their products and everything. So yes, there are multiple concept available in the market, multiple work and the other things available in the market. Let's be in touch on those things, and we can further explore the opportunities for collaboration. Yep. Yes, Ayan, you raised your hand.
Sir, actually, I also put my question in the chat box. I just
Mhm.
wanted to ask, how will you manage multiple subtwins in a digital twin if your simulation is very complex due to
Mhm.
multi-scale nature of chemical plants?
Mhm, mhm. Yes, yes. Considering, yeah, the question is right, Ayan. So for managing each and every simulation thing, like if you take example of digital twin in context of the thermodynamics, unisim thing and all, your engine is different, your hardware is different, where these things are running and calculating and giving the output. For managing the digital twin in context of the predictions and all, your engine is different. Okay, so having this parallel thing in market, in your plant or in your manufacturing setup will not harm you. Managing, of course, required the different skill sets. So the technical depth should not happen. So the person who is buying that software should take that intelligent call, what output he want from that software. Whether he want thermodynamics calculations and output, then he should have that thing only. Whether he want the predictions and all, he should have that setup, and he should hire that skill set, or he should take the services of that skill set. Okay, if he want both the thing, he should definitely go for such a vendor who is managing both the things, or he himself should have in-house capabilities who can manage those softwares. in
Okay, sir.
context of hardware, software as well, in context of people skill set as well.
Okay, sir.
Yeah. But
Yeah,
again,
Chetan, I
the
will
hardware,
give
software, and
practical
the skill set come with their packages and money. So
view
those
of this
intelligent decisions can
Chetan,
question.
be
there
done.
is a question in the
See, in
chat
oil and gas, we
Q&A
have different units.
by Ayan.
When the fluid comes
Yeah,
How
from
to
the
ma'am,
manage
offshore
actually, I
wells,
just
multiple
asked him
subtwins
verbally
without
right
first is
crashing
the
the
slug
simulation
catcher
for
or three-phase
multi-scale
separator.
nature of
Then
chemical
gas goes to
plants?
the gas treatment plant where you have got a dehydration, dew
Ma'am, I
pointing,
actually asked him
compression unit.
verbally.
Whereas separator, there is a desalter, stabilizer
Rajesh,
column, storage,
Rajesh ji,
or any
Rajesh ji,
further purification system, Merox, like
yes.
that. Okay.
Rajesh ji, can you repeat
So
again?
I think
Sorry.
what the question Ayan had asked, that practically in a digital twin, I want to know the effect of change in composition as well as inlet pressure. Okay. So
Yeah.
whether different models, different twin models
Mhm.
are required to be developed, definitely it will be required, what I understand. But can they be handled in a same frame,
Yes. Yes.
same screen?
Yes. Yes, Rajesh. Yes. If yes, they
Because
can handle.
ultimately
They
operator
can
has
be
to give
handled in the
one
same frame.
parameter only. He cannot have
Correct.
multiple set of process parameters.
Correct. Is I'm audible, guys? If that is your question, Ayan, yes, they can be handled in the one frame. In fact, I have whatever the example which Rajesh has said, I have by my own hand, I have designed this whole plant into the entire Unisim frame, and I have delivered that plant. Yeah, with all the DCS functionalities and everything, with all thermodynamics functionalities as well. So yes, definitely that can be designed into the one plant, and that is easy to operate as well, easy to learn as well, as a simulation person or as a operator training. So that is easy as well. So that can be done, and people has already delivered such plant. And if that was your question, which Rajesh has explained, so yes, that can be maintained in one frame. I don't know if I'm audible or not.
Yes, you are audible.
Yes,
Perfect.
yes.
Perfect.
Yes,
Yeah,
sir.
Yes, yes,
thank you.
clear.
Thank you, Chetan.
Yeah. So yes, the last delivery which I
Sir,
have done in the Singapore Rajesh was the Merox plant, entire plant rather. Yeah.
sir, one question in the
With
chat
what?
box. Can I read it?
Yes, please read it. I guess
Ah.
I can.
How to manage multiple subtwins without crashing the simulation for multi-scale nature in the chemical plant?
Sir, I actually just asked the
He
question
asked it.
verbally.
Yeah.
Yeah.
Acha, that is what. Okay.
Yes.
And Prasad Parulekar has asked, while
No,
implementing
that is,
AI-based.
I think, sir, that is in earlier, 15 January.
Okay. Perfect.
Ah,
Okay.
okay.
So Chetan, that Merox unit what you handled was
Uh-huh.
UOP licenser?
Yes. In
Okay.
fact, if you know more about UOP, the one project which I have delivered is for the manufacturing of forget the xylene plant, the p-xylene and xylene plant. That I also the UOP license things we have built that reactor for the p-xylene production, and we have delivered it. For this Merox as well, yes, UOP based license, and for that particular licensing information, we have given our Unisim to the UOP. UOP had built that thing, and they have sent us the particular this part of the simulation, because it is kind of pattern for them, and we have included that calculation as a what you can say, as a black box in our Unisim software, and then entire plant was designed. Rajesh ji.
Yeah, great work.
Yeah. Anything else, guys? And I guess
I
we can
think there is
close.
no questions.
Yep.
Participant, any having question you can ask, or you can put in the chat box also.
Or you can ping me later on the WhatsApp as well.
Yeah,
I will
that
be
is
available.
also. Yeah.
Yeah.
We will provide the PPT as well as his number also. No problem.
Yes. Definitely.
If there is no question, then we'll go for the end. So on the behalf of the Faculty Development Program Organizing Team, we extend our sincere thanks to you, sir, for delivering an insightful and enriching lecture on the digital twins in the chemical manufacturing industry. Your session provided a clear and practical perspective on how the digital twin technologies are transferring into chemical manufacturing through the improved process optimization, predictive capabilities, and data-driven decision makings. The way you connected with the real-world industry's application with the emerging digital framework was highly informative. In this presentation, you explain the journey of the digital twin in very good and the simple way, so all the participants can understand it very easily. So the lecture added significant value to the faculty development program as well as offered by the faculty member and the students. Meaningful insight that will support the teaching, research, and the industry collaboration. So we are grateful to your times, expertise, and the willingness to share your professional experience. We truly appreciate your contribution and hope to have opportunity to engage with you again in the future offline. As you suggested, we will try to make the offline lecture in the future, and definitely we take the advantage of your knowledge for our student as well as the faculty. Thank you once again, sir, for your very valuable and knowledgeable lecture for us. Thank you, sir.
Thank you. Thanks, Nita ma'am. Thanks, Ravindra. Yeah.
Thank you, Chetan. It was a great presentation. I congratulate you for your achievements. Great achievements.
It's not achievement. It's just journey. It's going on. Yeah. So and if we walk along with each other on this journey, then we can walk for long. Yeah. It's good to share with each other. Yeah.
Sir, we will visit that Nadi. What would you suggest? Definitely, I will
we'll
contact
go.
with. Yeah,
Definitely.
I'm interested in
very
that
interesting.
area. So,
Yes.
I have seen in
Yes.
the net also. That is very interesting. How the
Yes,
people
it's very
are.
interesting.
Yeah. That is medical in
Right.
the medical science. That is very interesting.
Correct,
Definitely,
correct.
I will approach you. Okay.
Yes, for sure.
Okay.
Yeah.
Okay, sir. Thank you.
Thank you.
So I will stop
Thanks,
the
guys.
meeting. Okay.
Yeah. Thanks. Have a great day. Have a great weekend. See you later, guys. Bye-bye.
So we are having a session on the 2:30 next session, and then we will after that valedictory function will be after that session. Okay.
Just
See you at the 2:30 then.
one quick
Yeah.
input for everybody, guys. So the session which you people are attending after that, Harsha, she was also from Honeywell, and she's also having great knowledge of this digital twin thing. Ask this question again to her, so you will get to learn her perspectives as well.
Yeah. That is good. Good. Definitely, I will try.
Yeah.
Okay.
Perfect. Thank
Okay,
you.
sir.
Bye-bye.
Thank
Have
you,
a great
sir.
day.
Right.
Bye.
So I will end the meeting now for all.